Hi, hello again. This is Vasilis from epso Academy. Um, I will solve another question today, but if you want to see many videos for epso exam, you go to epsoacademy.com and then you see many videos with solutions one by one that will be very helpful in the epso exam, especially in the open one. Okay, so here we have a train that starts from A in the direction of B at 9 a.m. and takes 6 hours to travel to B. Another train starts from B going to A. It starts at 10 a.m. and takes 8 hours to travel to A. So what time both trains meet? Suppose they meet somewhere here in between at the point C. So C is the meeting point. Okay, suppose the distance is d, then we have the d equals the speed of A multiplied by the number of hours, and this is 6 hours. Suppose VA and VB is in kilometers per hour. Okay, so from here we have that the speed of A is the distance divided by 6. In the same way, I have that the distance is the speed of the train B times 8, because it takes 8 hours. And so we have the speed of B is the distance divided by 8. As you see here, there is a time difference of 1 hour between them. So what I'll do actually, since this one started earlier, I want to see what distance A has traveled until the time that B started moving. Okay, so next thing I need to find is the distance traveled by A in an hour. So this is D divided by 6, since this is the speed kilometers per hour. Okay, so this is D over 6 kilometers. So what's the remaining distance? So A has gone somewhere here at the point A prime, and there is a distance now between A prime and B, because now it's the time here. When A reaches that point, the time is 10 a.m. and it's exactly the time that B starts moving towards A. So the distance traveled by A is D over 6, and the remaining distance so the distance in my diagram here, A prime B, is actually what is D minus the distance traveled A prime. So it's D minus D over 6, and this is 5D over 6. Now the interesting part is here. I will suppose now that this is 10 a.m. and it's like they both just started moving towards each other. So A started moving towards B and B towards A at the time 10 a.m. and the speed of this one is VA and the speed of this one is VB. Now we have talked about relative speeds, so since they are moving towards each other to meet, it means that the relative speed is VA plus VB. So the relative speed is D over 6 plus D over 8. But we know that if we take into account the relative speed, it's exactly the problem like this. Like starting at a distance, as we said, of 5D over 6. Let's see, 5D over 6. 5D over 6 distance at 10 a.m. with speed VA and speed VB, and I need the time it takes to meet. Yeah, this time is the same exactly as if A is moving at the speed VA plus VB and B doesn't move. So the times that it takes a hypothetical train A that moves with speed VA plus VB to cover the distance 5d over 6 is exactly the same time it takes both moving in opposite directions. So the time it takes here is what? The time is the distance, that's 5d over 6 divided by d over 6 plus d over 8. And this is 20 over 7 hours. And this is actually 2 and 6/7 hours. Now 6/7 of an hour, if you multiply by 6, you will see that this one is 2 hours 51 minutes and 25 seconds. So what time do they meet? Since the time after 10 a.m. it takes is 2 hours and 51 minutes, they meet at 12:51. It's PM now because it's after 12. Okay, so that's all. I hope you enjoyed the question. See you soon. Bye bye. Bye.